Okay, today we're going to study the product and quotient rules for derivatives. Okay, these rules are important because, for example, if you have a function, something like f of x equal to x minus 2 multiplied by x squared plus 2x plus 4. Well, you cannot just say the derivative of this function is the derivative of this factor multiplied by the derivative of this factor. If you do something like this, like that, you will have something like this: 2x plus 2, and then if you multiply, you will say my derivative. Okay, my derivative is 2x plus 2, and that is my answer. But that is not correct. Okay, this is wrong. Okay, please don't do this from now on the course. You have to use the product rule. Whenever you have a product, you are going to use the product rule. Also, this is pretty much the same if you have a quotient. Okay, just let me erase all of this. Okay, we no longer need that. Okay, for example, if you have the division of two functions, let's say, for example, you have f of x equals, we have a division, x cubed minus 27 divided by x to the third plus 27. Okay, then you cannot just say, okay, my derivative is the derivative of my numerator divided by the derivative of my denominator. Okay, if you do something like that, if you do that, you're going to get 3x squared and 3x squared down on the denominator. So you will be saying, okay, my derivative is 1, but that is not true. This is also incorrect. Okay, in that case, you will have to use the quotient rule because you have a division, the division of two functions, so you need the quotient rules. Okay, but they are very easy. Okay, we are going to study that now. Okay, let's see the next slide. This is this one. This is the product rule. If you have a function u that depends on x, and another function called v that also depends on x, then your derivative is the first function. You just copy your function, the first one, and multiply by the derivative of the second one, and then you're going to add the second function, the second product, and multiply by the derivative of the first function. Okay, that is whenever you have the product of two functions. Okay, like in the example before, in the previous slide. Okay, we're going to work on an example in a moment. Okay, also, whenever you have a quotient, okay, for example, this one, okay, what is this rule telling you? Okay, it's telling you have another, again, two functions, u and v, and you have the quotient. Okay, v is dividing u. Okay, u is divided by v. That rule says, take the function in the denominator and multiply it by the derivative of the function in the numerator. Then subtract the product of your function in the numerator multiplied by the derivative of your function in the denominator. And all of this expression is going to be divided by the square of your function in the denominator. Okay? We are still with the basic rules. These are the product and quotient rule. Whenever you have a product, okay, you are multiplying two functions, or whenever you are dividing two functions, you are going to use these two rules. Okay, now as I told you, we are going to work with some examples. Let's say the functions that we had before. Okay, I think we can have something like this. For example, I have a function f of x that is x minus 2, and it's going to be multiplied by x squared plus 2x plus 4. Okay, then I'm going to use the product rule, okay, to find the derivative, that is f prime of x, the derivative of f of x. Okay, so I'm going to follow my product rule. Okay, it says copy the first factor, the first function. Okay, just copy. Okay, I just copied. Now multiply by the derivative of your second function. Okay, so the derivative of my second function is 2x plus 2. Okay, and then please add your second function. Okay, so I just copy my second function, and then multiply that by the derivative of your first function, which in this case is 1. And then, well, I'm done differentiating. That's the derivative. I'm just going to simplify. So let's see, we have x times 2x is going to be 2x squared, and then multiply by 2x minus 4x minus 4. And then the other product, I'm just going to get rid of the parentheses because I'm multiplying by 1, so I'm not going to do anything to that function. Okay, I had a parenthesis here, so I'm just going to get rid of this parenthesis. Okay, then I'm just going to simplify to get the final answer, which is going to be 3x squared, right? 3x squared, and then all the x's is going to be minus 2x plus 2x is going to be 0, and then 0 again, right? So you are just left with 3x squared, right? Okay, that's the answer. Okay, so as you can see, it's pretty easy. You just need practice to get used to the rule, but I don't think you will have any problem with using this function. We are still with the basic functions. Okay, so let's see the example of the other rule. In this case, the quotient rule. Okay, whenever you are dividing two functions. Okay, so let's see an example, the one we had before, which was f of x, and it's going to be multiplied by, f of x we had x cubed minus 27 divided by x cubed plus 27. Okay, we have a quotient of two functions. So let's see, I want the derivative. As I told you before, please do not find the derivative of the numerator and divide by the derivative of the denominator. Okay, that will be wrong. You have to use the quotient rule. So the quotient rule said I have another quotient. That's why my line here. And it says copy the function in the denominator. Okay, just copy. Okay, so I'm just copying it. That's it. Then multiply by the derivative of your function in the numerator. So the derivative of the function in the numerator is 3x squared. Okay, the derivative of 27, a constant, is 0. Then subtract, okay, negative sign. Copy the function in the numerator. Okay, there it is. And then multiply it by the derivative of your function in the denominator. So it's 3x squared. Okay, there it is. And then divide everything by the square of your function in the denominator. Okay, so that's the square of my function in the denominator. Then we are done differentiating. Okay, that's the derivative. Okay, the differentiation process is over. I'm now just going to simplify my answer. Okay, so I start multiplying the first two factors in the numerator. It's going to be 3x to the 5th and plus what's that number, 81x squared. Okay, 27 times 3 x squared is 81x squared. So minus 3x squared multiplied by x to the 3rd is going to be 3x to the 5th. Then I have a negative sign, but a negative times a negative is a positive. and then I have 81x squared. Okay, and everything is divided by x cubed plus 27 squared. Okay, so I'm just going to simplify my numerator. Okay, so I get rid of these terms, and I'm left with those two terms, 81x squared plus 81x squared. So what is 81 plus 81? They are like terms, right? So because they are like terms, oh, sorry, I don't know where that came from. 81 plus 81 is 162, and x squared, and everything is going to be divided by this function, the square of my denominator. Okay. Some students ask me, do I have to take the square of x cubed plus 27? Okay, if you want to, you can do that. But I think I can leave it like this. Okay, I'm not going to simplify anything, so I can leave it like this. So you have two examples here. I think it's pretty easy. Okay, just follow the rules. Okay. You can have your rules whenever you are working with your homework or exercises in class. Just follow them, and I think you should be fine. You should be okay with it. Yeah. If you already know, of course, the previous rules. Okay, I think there should be no problem. Okay, I hope this video helps you understand this part of our course. Okay, this small part of our course, differential calculus. Thanks for watching.